A, ooh, that's not an A. How tiny is that? That's okay. A0 and B0. So if I plug this in the distance formula, I kind of switched it up on my answer key, but it's still the same. Our distance is going to equal the square root of our second x value, so B minus A squared, plus our y 0 minus 0 squared. So in fact, 0 minus 0 squared, that's just gone. So we just have B minus A squared. Well, square root and square are going to cancel each other out. So our distance is going to equal B minus A, but there's one key difference here. If I square something and then take the square root, it needed to have been positive, because once I square it, it becomes positive, and then when I take the square root, it's still positive. So this B minus A must be the absolute value of B minus A, because the result would be positive. A number squared, and then you take the square root of it, will always be positive. My example might be, I guess 3 minus 12 would be, terrible one. But if we had 3 minus 9, I guess, we'd have negative 6, but negative 6 squared would be a positive 36, and the answer would be 6. Okay? Other questions? And the midpoint's the same. It's just A plus B over 2, comma 0. Other questions from the homework? We sure? Positive? No questions on those word problems at all? Okay. Then we will roll right into today's lesson. So today's lesson should be a generally favorable lesson. It should go really quick. Homework should go really quick as well. We're just talking about linear equations in two variables. That is just ax plus by equals c, or y equals mx plus b when it is in slope-intercept form. In other words, there's no powers, there's no x squares, no x cubes, no square roots. It is just plain x. It is just plain y. We're going to go through two ways to actually graph lines using graph lines. We're going to use intercepts, and then we're going to use slope-intercept form. And the reason why I'm showing you both ways is because both are useful in their given times. This one is useful. So we'll go through and I'll tell you when it's useful. So it says since, it should say 2 points, not a 2 points. I don't think you have a 2 points. Since 2 points determine a line, all we have to do is find the x-intercept, y-intercept, plot them, and draw a line through them, and we have ourselves a line. Just remember, if I'm looking for a y-intercept, my x value is 0, so we're just going to let x equal 0 and I'd find my y-intercept. To find my x-intercept, I'm just going to let y equal 0 and solve for x. That will give me my x-intercept. So when to use this? If we were the directions here, it says graph the given lines. What I'm more concerned about is it says show the intercepts. So I need to plot both those intercepts anyway. So I might as well just use this method since it wants both those intercepts anyway. And when I do this, I make a t-chart. If I'm plotting using two intercepts, I use a t-chart. I let one thing, so I'm going to let my left side be my x-intercept. I'm going to let my right side be my y-intercept. To find my x-intercept, I'm going to let my y equal 0. To find my y-intercept, I'm going to let my x equal 0. And we're going to go ahead and substitute those into the formula that we have right above, and then we'll solve for that problem. So we have y equals 0, so we're going to have 2x minus 3 times 0 equals 9. Well, that just cancels out, and I just have 2x equals 9. Divide both sides by 2, and I have x equals 4.5. I actually have a point here. I have the point where my x equals 4.5 and my y equals 0. So does the point 4.5, 0. So we just go to our graph, plot 4.5, 0, which is right there, and I have my x-intercept, 4.5, 0. All right, to find my y-intercept, I'm going to plug x equals 0 in. So we're going to have 2 times 0 minus 3y equals 9. My 2 times 0 cancels out. I just have negative 3y. I'm going to divide both sides by negative 3, which is going to give me y equals a negative 3. Once again, this is still a point. It is that point where x equals 0 and y equals negative 3. So I'm going to plot the point 0, negative 3. Connect those. And we now have the line. So if you use slope-intercept form to graph this one, you would then have to find your x-intercept afterwards. This one just kind of cuts out that middleman, and it's not hard to do. It's not hard to plug zeros in and solve for an equation. All right, our next one, we're going to do the same thing. I actually have to move this 4.50. I kind of threw that in the wrong place. Let's see if I can. Ooh, that's going to do the whole thing. Oof. I'm just going to rewrite that up here. All right, same thing. We're going to make a t-chart. We're going to find our x-intercept and our y-intercept. So to find my x-intercept, we're going to let our y equal 0. To find my y-intercept, we're going to let our x equal 0. If my y equals 0, we're just going to have 0 equals 40 minus x. Add x to both sides, we have x equals 40. This is going to be the point 40, 0. So I'll make sure I mark 40, 0. I'm going to tell you right now, I'm going to be a stickler on the test. If I ask for 2 intercepts, I better see both of your intercepts on the line and labeled. All right, I will take off points very, very quickly for sloppy graph work. And I'll tell you something else when we're doing our homework on something else I'm looking out for. So if I ask for 2 points, I need them both. So in fact, I would have lost points on that other one because I should have put 0, negative 3. I just got sloppy because this is the 4th time of writing that number. I just kind of forgot it. All right, so we have 40, 0 here. Then we do our y-intercept. I plug 0 in for x, so we are going to have y equals 40. Once again, that's just the point x equals 0, y equals 40, so it's 0, 40. Make sure I label that as 0, 40. And then I have that line. And why I'm going to be a stickler on that is because some people, even though I say label both things, they will still use slope-intercept form and they won't label it all. They'll just estimate where it goes through. If I'm asking specifically to show the intercepts, they better be exactly where they match up. Any questions on that? So this is a method you should know how to do. It makes solving these a lot quicker, and you don't have to worry about doing a 3rd step. All right, the other way you can graph lines is using slope-intercept form. Well, slope-intercept form is that y equals mx plus b, where m is my slope, and slope is change in y over change in x. Delta just stands for change, that little pyramid shape just stands for change. Well, change in y is our up and down. X values are our left and right. So you're more likely to see this as just rise over run. Up and down over left and right. All right, that b value right there is actually going to be your y-intercept. That's why it's slope-intercept form. And in fact, your y-intercept is going to be 0, comma b. That will be your y-intercept. All right, let's go apply it to that bottom left-hand one. Well, see that negative 2 over 3? That is my slope. And what I always do is I throw that negative on the top of the fraction. So I always look at it as negative 2 over 3. Where it's going to rise, negative 2. So it's in fact going to go down and then right. The bad part is with just slope, I can't do anything because I don't even know where I'm going down at and right. So you're always going to plot your y-intercept first. And don't forget your y-intercept will be this entire negative 2. So if I ask for your y-intercept, you're going to say my y-intercept is actually 0, comma, negative 2. So in fact, that blue arrow should move over a little bit. In other words, we find where y equals negative 2 and we put a big old dot there. That is my 0, negative 2. Then we're going to do our slope, which is negative 2 over 3. So it's going to go down 2. So that's the negative 2 portion. And it's going to go right 3. That is our positive 3 portion. Plot our point there. And we draw our line through it. Note, I did not ask for your intercepts, so you would not have to find your x-intercept. If I asked for your intercepts, you would have to additionally find your x-intercept and go through it. In this case, it wouldn't have been that hard because the reverse of down 2 over 3 would be up 2, left 3, and that actually would be your x-intercept. Our last one, it does say to graph and slope intercept form, so I need to put it in slope intercept form, although it'd probably be easier just to plug a 0 in and solve that way. But we were asked to use slope intercept form, so we have to use slope intercept form. So we got to move the x's to the right side. So we're going to have 2y equals 5x minus 4. I'm going to divide everything by 2. Maybe I'll show that. Divide everything by 2. We are going to have y equals 5 over 2x minus 2. Once again, that number in front of the x is our slope. So our slope is 5 over 2. And our y-intercept is 0, negative 2 again. Just a reminder, that entire negative 2 comes down there. All right, since my y-intercept is 0, negative 2, we just find the point 0, negative 2 and put a big old point there. 0, negative 2. My slope is 5 over 2, so that means I got to go up 5 units. 1, 2, 3, 1, 2, 3, 4, 5. So I got to go all the way up here. That is my plus 5. And then I have to go right 2 units. Let's make that. Let's go back to red, actually, because I got to put the plus 2. Put my point right there. And that is my line. Questions on either finding our x and y intercepts in graphing or slope intercept? You have to know how to do both methods because I can ask for either method on the test, or I might just say make sure you label your x and y intercepts. Pay attention to this part because it's so easy to solve it, but it's going to become so more difficult when we get to more complex things. So understand what I am doing. I get that 2x minus 6 equals 0 is super easy to solve because you add 6 on both sides and divide by 2. Read what it says, though. It says use the graph to solve the equation. You have to know how to use a graph to solve an equation because there are times when I'm not going to give you the formula. I'm just going to say solve this for where y equals 0 or something like that. All right, so this says 2x minus 6 equals y, or y equals 2x minus 6. It says use the graph, so the first thing we need to do is graph it. So our y-intercept is that 0, negative 6. And we have a slope of 2. So our slope is 2, but I usually put 2 over 1 to remind myself that it's up 2 over 1. And maybe I'll write down my y-intercept as well. My y-intercept is 0, negative 6 because of that negative 6 at the end. All right, slope is 2 over 1. What I want to do is I'm going to plot a few of these. Let's plot the first one. The first one would be up 2 over 1. Then I would go up 2 over 1. Then I'd go up 2 over 1. And that's as far as you need to go. We needed all that just to finish this problem. All right, it says 2x minus 6 equals 0. I know the answer is 3. I know. But we're going to use the graph to solve that. what you want to look at is the fact that it says 2x minus 6 equals 0. The thing that's changing is here we had a y, here we have a 0. So what they're asking really is, what's your x value when your y equals 0? So this leads to the fact that y equals 0. Now we have to figure out where y equals 0. So what I'm going to do on the graph, and what I want you to do in your head every time, is just think about the line y equals 0. These are all my values where y equals 0. And where does this intersect this thing? Well, it intersects right at that point there. Let me go ahead and circle that. So on this line, y equals 0 at the point 3, 0. And the point 3, 0 has an x value, and the y value was already 0. We should already know that. So that means our answer is x equals 3. I know we already knew that, but when we get to more complicated ones, the graph's going to be a much easier way to solve these problems. Our next one says, what happens when I replace y with negative 2? So once again, all we're really asking about is what is our x value when y equals a negative 2? Once again, in our head, we should be just thinking about kind of this line. And then it actually collides with our graph right there at the point 2, negative 2. So y equals negative 2 at the point 2, negative 2. So x is just going to equal 2 in that case. One more time, I know it's easy, but I really hope you paid attention because we will use this when we're doing quadratics and all that kind of stuff where you're not going to easily be able to solve it. And I'm going to tell you right now, this right here was one of the most missed questions on 2 of my tests. Because on 2 of my tests, I just gave you a graph, and I said, where is y equals 0? What is your x value? And more people got it wrong because a lot of people just kind of like some of you are doing right now. I'm not saying in this class, but in another class, just kind of phased out and they're like, I can solve this by hand. I don't care that you can solve that by hand. I'm going to give you problems that you can't solve by hand, that you have to just look at a graph and know how to read it like this. So make sure you know what I did up here. All right, and that would apply to this problem. Once again, we're going to notice our y got replaced with 0. So I'm looking for y equals 0. Remember, these are our xy values. This is an xy value. So you just need to figure out which one of these values have y equals 0. Well, that's just the point right here. That's where y equals 0. So this problem requires no algebra, and it's just x equals negative 36, and you move to the next problem. If you wasted time actually solving this, subtracting 30 and then multiplying by 6 over 5, you wasted a whole bunch of time when you should have just been able to circle it and just write down x equals negative 36. All right, questions on anything we covered? All right, then I am going to go over a bit of picky stuff I'm going to do with these graphs. Notice all of those xy planes, none of them have values on them. They're all just blank. You are required to come up with an appropriate scale. And what I mean by that is I'm going to show you number 69. I think 69 is a good one to show. I came up with the 2 intercepts, 0, 2,500, and 5,000, 0. So I needed some scale that accommodated it. And so what I did is I counted every 2 equaled 500. Now, I do not have to write 250, 500, 750. You can skip around as long as that scale stays to scale. So if I said 2 ticks is 500, these 2 ticks would be 1,000. These 2 ticks would be 1,500, and I marked that one. These 2 ticks would be 2,000. 2 more tick marks would be 2,500. I marked that one. Down here, I made every 2 tick marks 1,000. I could have did 1,000, left it all blank, and then did 5,000 over here. I'm not looking for you labeling every single tick mark you do, but make sure you pick a scale and you stick to it, and I see your X values and your Y values. You don't have to mark all the way down. This is exactly what I'm looking for. All right, I'm not looking for you to mark it all the way down here or all the way over here. On the test, I will be a stickler. If you do not give me a scale or stick to that scale, you are going to lose a ton of points. Because we are in pre-calculus right now, we should be able to label a graph correctly. All right, any questions on that? So the two things I'm looking out for is, since both these ask for X and Y intercepts, you should either write it down here or you should write it up here. I just need to see that you wrote it somewhere on there, and I'm looking for scales. All right, the rest of the time is yours. In a second, I'm going to walk around and I'm going to check your homework.